Light is one of the most fascinating phenomena in our universe. It surrounds us every day, allowing us to see the world in all its vibrant colors and shapes. But what exactly is light? In this video, we'll embark on a journey to explore the true nature of light, how it behaves, and why it's so essential to life as we know it. From the glow of the sun to the flicker of a candle, light takes many forms and plays countless roles in our daily lives. Let's begin by understanding where light comes from and why it's so important. At its core, light is a form of energy. It travels in waves and can move incredibly fast, about 299,792 kilometers per second in a vacuum. This speed is what allows sunlight to reach Earth in just over 8 minutes. Light is part of a larger family called electromagnetic radiation, which also includes radio waves, microwaves, and X-rays. But what makes light special is that it's the part of electromagnetic radiation that our eyes can detect. This visible light is what lets us see everything around us. Light can come from many different sources. The most important source for life on Earth is the sun, which provides natural light and energy. Other natural sources include stars, fireflies, and even some types of fungi. Humans have also created artificial sources of light, such as light bulbs, candles, and LED screens. Each source produces light in its own unique way, but all share the common trait of emitting energy that travels through space and reaches our eye. Light doesn't need anything to travel through. It can move through empty space, unlike sound, which needs air or another medium. This is why we can see the sun and stars even though they're far away in the vacuum of space. Light travels in straight lines, but it can also bend or change direction when it passes through different materials like water or glass. This bending is called refraction, and it's why a straw looks bent in a glass of water. Light is just a small part of the electromagnetic spectrum. This spectrum includes many types of waves, from long radio waves to short gamma rays. Visible light sits right in the middle with wavelengths that our eyes can detect. Each color of visible light has a different wavelength, with red being the longest and violet the shortest. Beyond what we can see, there are ultraviolet rays, infrared, X-rays, and more, all forms of light just invisible to us. When we talk about light, we often think of the colors we see every day. Visible light is made up of many colors, which together form white light. When white light passes through a prism, it splits into a rainbow of colors: red, orange, yellow, green, blue, indigo, and violet. This happens because each color bends by a different amount as it passes through the prism. That's why we see rainbows after a rainstorm, when sunlight is split by water droplets in the air. For a long time, scientists believed that light behaved like a wave. This wave theory explains many of light's properties, such as how it can bend around corners, diffraction, and create patterns when it passes through tiny slits, interference. Waves have properties like wavelength and frequency, which help determine the color and energy of light. Understanding light as a wave helps scientists explain many of its mysterious behaviors. Later, scientists discovered that light also behaves like a stream of tiny particles called photons. This particle theory helped explain things that the wave theory couldn't, like the photoelectric effect, where light knocks electrons off a metal surface. Each photon carries a specific amount of energy depending on its frequency. This discovery led to the development of quantum physics and changed our understanding of light forever. Today we know that light has a dual nature. It can act both as a wave and as a particle. This concept is known as wave-particle duality. Depending on how we observe it, light can show properties of waves like interference or properties of particles like transferring energy in discrete packets. This duality is one of the most intriguing aspects of modern physics and shows just how unique light really is. Our eyes are specially designed to detect visible light. When light enters the eye, it passes through the lens and focuses on the retina at the back. The retina contains cells called rods and cones which convert light into electrical signals. These signals travel to the brain where they're interpreted as images. This process allows us to see everything from the blue sky to the green grass and the faces of people we love. One of the most familiar behaviors of light is reflection. When light hits a surface like a mirror or a calm lake, it bounces back. This is why we can see our reflection in a mirror or the shimmering image of trees on water. Reflection is also how we see most objects. Light bounces off them and enters our eyes. The angle at which light hits a surface determines the direction it reflects, following the law of reflection. Refraction occurs when light passes from one material into another, like from air into water. This causes the light to bend, making objects look distorted or shifted. A classic example is a straw in a glass of water. It appears bent at the surface. Refraction is also responsible for the focusing power of lenses, which are used in glasses, cameras, and telescopes to direct light and form clear images. Light can also bend around obstacles or spread out after passing through small openings. This is called diffraction. When two or more light waves overlap, they can combine to form patterns of bright and dark bands known as interference. These effects are seen in everyday life, like the colorful patterns on a CD or the shimmering colors in soap bubbles. Diffraction and interference reveal the wave nature of light. Polarization is a property of light that describes the direction in which its waves vibrate. Normally, light waves vibrate in all directions, but when light is polarized, its waves vibrate in just one direction. Polarized sunglasses use this property to block certain types of glare, making it easier to see on bright days. Polarization is also used in photography and LCD screens to control light and improve clarity. Shadows are formed when an object blocks the path of light. The shape and size of a shadow depend on the position and size of the light source as well as the object itself. Shadows help us understand the direction of light and can create dramatic effects in art and photography. They're also important in nature, providing shelter and helping animals stay cool on hot days. Light plays a vital role in nature. Plants use sunlight to make food through photosynthesis, a process that supports almost all life on Earth. Animals rely on light to find food, avoid danger, and communicate. Light also drives the water cycle, weather patterns, and the changing of seasons. Without light, life as we know it would not exist. Humans have learned to create their own sources of light. From the earliest torches and candles to modern electric bulbs and LEDs, artificial light has transformed our lives. It allows us to work, study, and play long after the sun goes down. Artificial light is used in homes, streets, vehicles, and screens, making it an essential part of modern society. Lasers are a special type of light with unique properties. They produce a very narrow, intense beam of light that can travel long distances without spreading out. Lasers are used in many fields, from medicine and industry to entertainment and communication. They help perform delicate surgeries, read barcodes, and even power high-speed internet connections. Fiber optics use light to transmit information over long distances. Thin strands of glass or plastic carry light signals, which can represent data like phone calls, internet, and TV. Fiber optic cables are faster and more reliable than traditional wires, making them the backbone of modern communication networks. Light's ability to travel quickly and carry information has revolutionized the way we connect with each other. Light is used in many medical applications. Doctors use lasers for precise surgeries, and special lights help diagnose and treat diseases. For example, ultraviolet light can kill bacteria, while infrared light is used in physical therapy. Imaging techniques like X-rays and MRIs rely on different forms of electromagnetic radiation, showing how light helps us see inside the human body and improve health. Artists have always been inspired by light. From the play of sunlight in paintings to the use of colored lights in theater and photography, light shapes the way we experience art. Different cultures celebrate light in festivals like Diwali and Hanukkah, symbolizing hope and renewal. Light is more than just a physical phenomenon, it's a source of inspiration and meaning. Light helps us measure time. The changing position of the sun in the sky marks the passage of days and seasons. Ancient people used sundials to track time by observing shadows. Today, atomic clocks use the vibrations of atoms measured by light to keep incredibly accurate time. Light's constant speed makes it a perfect tool for measuring and understanding time. Light is a powerful source of energy. Solar panels capture sunlight and convert it into electricity, providing clean, renewable power for homes and businesses. Plants use light energy to grow, and animals depend on this energy for food. Harnessing the power of light is key to building a sustainable future and reducing our reliance on fossil fuels. Light affects weather and climate in many ways. Sunlight warms the earth, drives the water cycle, and creates winds and ocean currents. Changes in the amount of sunlight reaching Earth can cause seasons and influence weather patterns. Light also creates beautiful phenomena like rainbows, halos, and the northern lights, adding wonder to our skies. Vision depends entirely on light. Without light, our eyes can't form images and we're left in darkness. Different animals have evolved to see different types of light. Some can see ultraviolet or infrared, while others see only a narrow range. Understanding how light enables vision helps us appreciate the diversity of life and the importance of light in our world. Light is used to send information quickly and efficiently. Fiber optic cables, lasers, and even satellites use light to transmit data across the globe. This technology powers the internet, phone calls, and television, connecting people everywhere. The speed and reliability of light-based communication have transformed the way we share information and interact with the world. Light is everywhere in our daily lives. It wakes us up in the morning, helps us read and work, and sets the mood in our homes and public spaces. Street lights keep us safe at night, and screens light up our phones and computers. We often take light for granted, but it's essential for comfort, safety, and productivity. Light plays a crucial role in safety. It helps us see hazards, avoid accidents, and navigate our surroundings. Emergency lights guide us during power outages, and vehicle headlights keep roads safe at night. Proper lighting in public spaces reduces crime and increases our sense of security, showing just how important light is for our well-being. Modern technology relies on light in countless ways. From the screens on our devices to the lasers in barcode scanners and printers, light is at the heart of innovation. Cameras, projectors, and even some medical devices use light to function. As technology advances, new uses for light continue to emerge, shaping the future of our world. Energy-efficient lighting, like LED bulbs, uses less electricity and lasts longer than traditional bulbs. This not only saves money but also reduces our impact on the environment. Advances in lighting technology help us use light more wisely, making our homes and cities brighter and more sustainable. Astronomers use light to study the universe. By analyzing the light from stars and galaxies, they can learn about their composition, distance, and movement. Telescopes collect and magnify light, revealing distant worlds and cosmic events. Light is our window to the cosmos, helping us explore the mysteries of space. Photography is all about capturing light. Cameras use lenses and sensors to record the light reflected from objects, creating images that preserve memories and tell stories. Photographers use different types of light, natural, artificial, soft, and harsh, to achieve various effects. Mastering light is key to creating beautiful and impactful photographs. Light is essential in entertainment. Stage lighting sets the mood in theaters, while colored lights create excitement at concerts and events. Special effects in movies and video games use light to make scenes more realistic and engaging. Light brings stories to life and enhances our experiences in countless ways. Quality and color of light can affect our mood and emotions. Warm, soft light creates a cozy atmosphere, while bright, cool light can energize us. Designers use lighting to influence how we feel in homes, offices, and public spaces. Understanding the psychological effects of light helps us create environments that support well-being and productivity. Plants depend on light for photosynthesis, the process that turns sunlight into food. Different plants need different amounts and types of light to grow. Gardeners and farmers use artificial lights to help plants grow indoors or in greenhouses. Understanding how plants use light helps us grow more food and protect the environment. Animals use light in many ways. Some, like fireflies and deep-sea creatures, produce their own light through bioluminescence. Others use light to find food, attract mates, or avoid predators. Light cycles like day and night influence animal behavior and migration. Studying how animals interact with light reveals the complexity of life on Earth. Light affects our health in many ways. Sunlight helps our bodies produce vitamin D, which is important for strong bones. Too much or too little light can disrupt our sleep and mood. Light therapy is used to treat conditions like seasonal depression. Understanding the health effects of light helps us live healthier, happier lives. Artificial light can sometimes have negative effects. Light pollution from street lights and buildings makes it hard to see stars at night and can disrupt the natural rhythms of people, animals, and plants. Reducing unnecessary lighting and using smarter designs can help protect the night sky and support healthy ecosystems. Light travels at an incredible speed, about 299,792 kilometers per second in a vacuum. This speed is the fastest in the universe and forms the basis for many scientific measurements. The speed of light is so important that it's used to define distances in space, like the light year, which is how far light travels in 1 year. Quantum physics has revealed even more mysteries about light. Light can exist in multiple states at once and can be entangled with other particles, meaning their properties are linked no matter how far apart they are. These strange behaviors are being studied for new technologies like quantum computers and secure communication systems. As we continue to study light, new discoveries and technologies are sure to emerge. From advanced medical treatments to faster communication and cleaner energy, light will play a key role in shaping our future. By understanding and harnessing the power of light, we can solve problems and create a brighter world for everyone. Throughout history, light has been a symbol of hope, knowledge, and divinity in myths and legends. Many cultures tell stories of gods and heroes bringing light to the world, or of light overcoming darkness. These stories reflect our deep fascination with light and its power to inspire and guide us. Light has always guided explorers, from ancient sailors navigating by the stars to astronauts traveling through space. Lighthouses, lanterns, and beacons have helped people find their way in darkness. Today, powerful telescopes and satellites use light to explore distant planets and galaxies, expanding our understanding of the universe. Light sparks our imagination, inspiring artists, scientists, and dreamers alike. From the magic of fireflies to the wonders of the night sky, light invites us to explore, create, and dream. By studying light, we not only learn about the universe but also about ourselves and our place in the world. Light is more than just a physical phenomenon, it's a source of life, inspiration, and discovery. From the smallest particles to the vastness of space, light connects us to the universe and to each other. By understanding what light is and how it works, we open the door to endless possibilities and a brighter future. Thank you for joining us on this illuminating journey into the world of light.